project you guys just got back? Oh, I thought you meant the one that's up for Wednesday. Let's talk about it. Let's talk about it. So we have a question. When you say the last one, what are you talking about? The coat. Oh, the coats! The coats! Okay. So let's talk. That's actually a good. Thank you. Let's talk about this. I want to talk about the project a little bit here.
Gotcha.
For a couple of reasons. We got more stuff. We got. Who's it right in front of me? Mr. Chair. Yes. Lost my train of thought. Two things. First of all is the coats problem, which is slightly different than the rest of them. And also the fact that the project will help you answer at least one of the exam questions, which is not due until next week. This is week 10, right? Crap, this is week 10. So don't forget your exams floating down there for next week. To answer a similar question, we don't have class on Monday. You do, right? Right? Because it's finals week.
I refuse to go one more day without you.
Better show up. I won't be here. You can show up. That's fine. Wednesday, I think it starts at 10:15, just like your class does. I'm pretty sure. You won't be taking an exam in here. You'll be bringing your exam done to class, yes? And I've got a survey I want you guys to fill. I have to have you do something in the room that day, which is why I have to have you come in that day. But it'll be a real quick survey. I can't imagine it taking more than 10-15 minutes tops. And then we're done. So yeah, that's next Wednesday. Next week's Wednesday.
At 10.
Say it again?
At 10?
Yes, I think it starts at 10:15. I think, because the idea is, well, the idea is you're supposed to have a 2-hour block for your final exam. Although I don't give a final exam, but I have to allow the time for people that do have one at 8 o'clock in the morning to have their 2 hours. So make sure you come that day. A, to turn your exam in, and B, to do the survey for me. That's my assessment for you. Okay, but anyway, so that's that. The project will help you. Let me answer one question first, Joanne, if you don't mind, then get into your question, which is great. The question that I think the project will help you answer on the exam involves a 12-song playlist. So if you haven't looked at the exam yet, you'll recognize this problem when you get to it. If you have looked at the exam, this will probably answer any questions you have about it. So there's the question on there. You've got 12 songs loaded into a randomizer on a playlist. Or like an iPod or your iPhone or whatever else, MP3 player, and you play exactly 12 songs from those 12. And my first question is, how many different song orders could you hear? Now please notice the difference in that question versus your project that you just got back that says list all the song orders you could hear. I would never ever do that with 12 songs because it's ridiculous. There are millions of orders and I don't want you to write them out. That was the difference in the wording. I don't want you to list them out. I want to know how many there are. How many there are. That this project you just did was all about listing out outcomes. But hopefully in listing them out, you figured out also there's some neat mathematics behind how many outcomes there are. And you'll see it again today in practice when I have you guys flipping coins and rolling dice. It's fun stuff. Actually, flipping the coins. So, for example, what was the very first question on the exam? Or excuse me, the project you guys just got back. The very first was it flip a coin, roll a die?
Heads, tails.
Heads, tails. How many coin flips?
16 possible.
There were 16 possible, so you must have flipped the coin 4 times. Yes. How did I know that? How could I possibly have known that if there are 16 outcomes, you must have flipped a 2-sided coin 4 times? Gary.
I don't know.
You don't know? Oh, you don't know? Okay, good. Oh, I thought you were going to give me the answer. Okay, good. How could I have possibly... She gave me the number of outcomes, 16. Kendra, help me. It's 2 to the 4th power, which was technically not part of the project, but that was my point, was hopefully you would have figured that out in the process. It's 2 to the 4th power because each coin can be flipped twice. So you've got the first set of branches is 2. Yes, exactly. I like that there. That's good. 2, then 2, then I'm out of appendages. 2. And then 2, and it becomes 16. 2 becomes 4, becomes 8, becomes 16, 2 to the 4th power. If you go flip the coin 6 times, I would never ask you to list them all out because that gets ridiculous, but it would be 2 to the 6th or 64 outcomes. You would just have to take that tree you just made and make it go 2 more sets of branches. And exponentially it grows. It's an exponential growth model, so it goes out to 32, then it goes out to 64. And it gets ridiculous. It gets pretty ridiculous as you go further and further and further out.
12, 12 is
I don't want to answer that, because I want you to answer it yourself, but realize that when you're doing the randomizer question on the exam, if you're playing a randomizer with 12 songs in it, you essentially have a 12-sided coin, don't you?
So you...
So I'm going to leave that out there. I'm going to leave that as my statement, because I want you guys to puzzle through the question. So you think about it this way. You're taking a 12-sided coin. This is what a randomizer is on an iPod, right? It's a die that the thing has in its brain. And when you hit the play button, it takes the die and rolls it, and whatever shows up, that's the song you hear. Next song in the playlist, grabs the die again, rolls it again, that's the song you hear. Do you see what I'm getting at here? So it's the same as flipping a coin 6 times, except you're rolling the die 12 times. See if you can figure out the pattern. And we're going to do more, as through the course of today, we're going to do some more examples of that too. Yeah, Michelle?
So you said that if you have 12 songs, it's like you have 12 two-sided coins. No, you have
12-sided coins if you're playing 12-sided, right? Think about how the randomizer, I only use that example because it was the very first one in your project. If the coin was 3-sided, I know you can't envision that, that's okay. Suppose you had a 3-sided coin, and you flip the 3-sided coin, I've tried, and you have a 3-sided coin, you flip it twice. The first set of branches is going to go 3, yeah? Heads, tails, other. And then each of those is going to have 3 on it, heads, tails, other. Which means you got 9 total outcomes. It's rock, paper, scissors all over again. 3 squared. 3 squared is 9, there's your 9 outcomes. If you were to do it again, it would be 3 to the 3rd power, or 27. So if you need a model to help, it's only one question on the exam. So it's not like you're going to bury yourself if you can't figure this one out by yourself. Talk to your friends, of course. But use the number of outcomes from the project you just turned in and look for a pattern in what's happening and the number of outcomes, because there is a beautiful mathematical pattern, and it's all about multiplication. Which is kind of what that project was all about, was those tree diagrams are doing the multiplications for you. But don't do them on the randomizer problem. Because, my God, I mean, think about it. One of the first 12 song playlist would be song 1 1 1 1 1 1 1 1 1 1 1 1. And the next two will be 1 1 1 1 1 1 1 1 1 1 1 2. And then 1 1 1 1 1 1 1 1 1 1 3. 1 1 1 1 1 1 1 1 1 1 4. You see, now how about the ones that start with 7? Or start with 20? It's like, this is ridiculous. Yes, it is ridiculous. So I don't want to see them listed out. What I just want to see is how many of them are there, and it's huge. Don't try drawing the tree either. Sweet Jesus, no. Don't try drawing the tree either. You don't want to do that either. It's easy. Okay, you the man. But the tree can help you think about. The tree can definitely help you think about the multiplication that has to happen. Fair? So Michelle, 12-sided coin, not 2-sided coin. A 2-sided coin if I had 2 songs in the MP3 player. Heads or tails? Iron Maiden, Van Halen. Iron Maiden, Van Halen. What?
Come on, Mr.
Or Mr. Mister. That'd be 3-sided coin, Mr. Mister. And if I had Pat Benatar, Effects, Refused, that's 6-sided coin. That's die. So you have to have a 12-sided coin, right? A 12-sided coin. And each time you roll it, it tells you what song to play.
So it's 12.
My question is, if you roll it 12 times, how many possible outcomes are there? And it's huge. If you're getting a huge number, you're doing it right. Fair? And compare to other students. Talk to each other once you've run the math to see if you're getting the same result. You should get the same result, of course. Fair? So that's just, I want to make that connection between the project and that one question on your exam. I mentioned it on the exam. Think about your 3rd project for this, but I think that was maybe too vague. So that's why I wanted to chit-chat about it a little bit. Good so far? Now, Joanne asked a very, very good question about the project, speaking of that. The last question, which was the drunk guests grabbing the coat, leaving the party. Now, believe it or not, as silly as this might sound, it's actually tied to iPod randomness too. How many of you guys have ever used the shuffle mechanism on an iPod? Shuffle. The shuffle mechanism on an MP3 player, either it's an iPod or something else, is exactly like drunk people grabbing coats and leaving a party. I swear to God, it's exactly like that. And here's why. So the question was, you got 3 drunks grabbing coats, leaving. 3 drunks coming to the mat, like, sit down, makes you think I've been. Yeah. So basically, you've got guest 1 leaving the party for, I'm going to call him guest 1, it doesn't matter to me what you call him, A, B, C, 1, 2, 3. Which coat can guest 1 grab?
1, 2, or 3.
Clearly, they stagger into the bedroom and grab a coat. Guest 1 could get 1 or 2 or 3. Go so far. We're fair so far. Now, he takes, or she, whoever, let me be gender specific, grabs a coat, staggers out, leaving 2 coats behind. Guest 2 now staggers in. Suppose guest 1 took coat 1. Guest 2 only has 2 or 3 to choose from. It's gone down by 1. This is not like a pure random, because if it was purely random, guest 2 could take coat 1 again, right? But he can't, or she can't, because it's gone already.
No, if they get in the home, bro.
Easy, easy. How about if he took coat 2? 1 or 3, yeah. And 3. And what this means is, guest 3 doesn't have a choice. Guest 3 grabs whatever, exactly, whatever coat's left. So if 1 and 2 have been taken, guest 3 has to take coat 3. If 1 and 3 have been taken, guest 3 has to take coat 2. 2 and 1 are gone, he has to take 3. 2 and 3, he has to take 1. 3 and 1, he has to take 2. 3 and 2, he has to take 1. And then the answer would be the outcomes. So now, I think the easiest way to write it out is just to write 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, or 3, 2, 1. I think that's the easiest way. And if you're doing it that way, that means you're using the mathematical idea of an ordered triplet. So you're used to like x and y coordinates in parentheses. So if you write the point 1, 2, I know what you mean. It means x equals 1 and y equals 2. If you just write 1, 2, 3, I know what that means. It means guest 1 took coat 1, guest 2 took coat 2, and guest 3 took coat 3. If you write 1, 3, 2, I know what you mean. Guest 1 got his or her coat, but guest 2 and 3 got their coats backwards, and so forth. So there's only 6 outcomes in total. Francis?
So how random are the course evaluations for somebody to win the iPod Mini?
Oh, tell me more! Ooh. Tell me about this.
Is that really random or what?
I don't know. Tell me about you. If you do the evals,
somebody's supposed to win the
wins, but they did that last year.
Hang on now. For every eval you do, you get a name and a hat.
No.
Yeah.
If you do all the evals that you could do.
That's what I'm wondering how random.
They took my advice. See, I was behind. Well, me and Barbara Klett, she's going down to San Diego now. We were behind the push to go to online evals versus paper and pencil ones. Paper and pencil ones are a resource waste of time. They take way too much time for our admins to actually collate, so we pushed and pushed and pushed. But I did a bunch of research into them to find out, because one of the biggest criticisms on online research, or online evals, is that students won't do them. They said the response rates are low. And it's like, no, they're not actually. If you look at the research, they're arguably the same. And the problem is that if you look at my response rates, for example, my paper and pencil hover around 55%, and my online hover around 50%. And you might say, well, 55 is bigger than 50. It's like, yes, if you ignore what's called a margin of error, which you shouldn't do, because a margin of error is part of a statistical calculation. If once you include the margin of error, they're essentially the same number. So, one of the articles I read threw an interesting idea out that said, okay, we can't teach people statistics on the fly, so that we can't make them believe in a margin of error. So make students more willing to take the evals by offering them a carrot. Now, schools have done it 2 ways. They've done negative reinforcement and positive reinforcement. Again, we're the example of the positive reinforcement. Do the evals, we'll throw your name in a hat for an iPod. I have no idea how they're doing it. I haven't been consulted for that. But OSU, or was it U of O? One of them does a negative carrot approach. No, it's not, it's positive. If you do them, you get access to your grades early.
It's U of O.
It's a U of O. Thank you, Carrie. If you do your online evals, you get access to your grades like a week before everybody else or something like that. There are some schools, I had the wrong memory. In the article they mentioned a school that will not release your grades to you until you've done your evals. I think that's a terrible idea.
Wow.
Is that OSU?
Yeah.
Whew, I think that's a terrible idea, because then you might inadvertently, imagine you're exhausted. It's spring term, you're like, get me the hell out of here. Oh, crap. I'm not going to get my grades until I do my evals. I'll show them. Then you're introducing bias potentially into the evals. One. You see? So there's different ways to. So I don't know about how the random process works. It's not hard to make it random.
You're making me do this. No.
1, 0, suck. So I mean, it's just. So there's a very easy way to pick a random student. Go into Excel. I'll show you in a little bit how to use random numbers in Excel. And suppose you have 1,000 people that have done evals. You simply generate a random number between 1 and 1,000. I.e., you take a 1,000-sided die and roll it 1 time. Whatever number comes up, they get the iPad.
Oh.
I mean, that's essentially what it is, yeah? That's what, every time you guys see a game show where they pull numbers out of a hat, or the lottery where they pull the balls out of the, it's a die. It's a die. Think about it. Have you seen them draw Powerball? When they draw Powerball, they've got the ping pong balls in the air chamber. That's a die. I mean, every one of those things, I'm going to go by memory here. But in Powerball, there are 6 numbers. Yeah, there's 5 normal numbers and the Powerball. I'm going to make up numbers because I don't know if this is right. I think each of the normal numbers are 1 to 55, and the Powerball's 1 to 50. I'm going to make it doesn't matter what they are. Let's just 1 to 19. It doesn't matter what it is. Let's just say 1 to 55 and 1 to 50. Well, you could do the exact same result if you simply, if you simply have a 55-sided die, right? A 55-sided die and throw it. Whatever side comes up is the first number. Pick it up, throw it again. Whatever comes up next is the next number. Pick it up, throw it again. The problem is, what the hell does a 55-sided die look like? It looks like a sphere. It's got so many sides, it's basically round, and it's hard to roll the number 1, and it doesn't have that pow factor that the ping pong balls floating around in the cage do. So, anytime that you flip a coin, roll a die, check the suit on a card, any of those things are simply die rolls or coin flips. That's why that program I gave you was called coins. They're all viewed as coins. It's just a coin as we view it has 2 sides. The one I just gave you has 2 sides. But a die is really just a 6-sided coin. It's got 6 faces that are all equally likely to come up. So it makes it a coin, a 6-sided coin. Pulling a card out of a deck of cards is simply a 4-sided coin. Check the suit. Or a 13-sided coin, check the rank. Or a 2-sided coin, check the color. You see? I mean, depending on how you reference it, correct? If I pick a student at random out of this room, that's a 30-sided coin. I mean, I guess there's 30 of you here today. It looks like there's about 30 of you. That's a 30-sided coin. I mean, if it's equally likely, if it's an equally likely outcome, it's a 30-sided coin. That's why when you guys are like, what about this iPad that gets given away randomly? Well, I mean, think about it, because so tight. It's a 1,000-sided coin at least. It probably is even higher than that. Probably. I would imagine you've got probably a few thousand people that are doing course evals. I mean, even if you apply my numbers, 50%, which is probably pretty high as far as completion rates across the board. How many students does COCC have taking classes right now? I think it's 18,000 if you include all the continuing ed and the part-time and the full-time. So if you did 18,000, right, if you take all the students, I think it's 18,000 head count. Not FTE, but head count. There are actually 18,000 people registered at COCC taking classes. If one person takes 1 3-credit class, they do a class eval, which means they go into that pot. It doesn't matter how many classes you're taking, it's just if you do all the evals that you're entitled to do. Well, that means it's a 9,000-sided coin, right? Because if all 18,000 of people, if of those 18,000, only half of them do their evals, that's 9,000. That's a 9,000-sided coin. So what's the chance of winning the iPad? It's pretty small. But it's as good as anybody else's. It's 1 in 9,000. It's 1 in 9,000. It's tiny. So it is tiny. It's not tiny. But that's why you don't hear about it. The person that got it's like, sweet. And they're probably not going to announce it.
Like a little clue.
A little clue?
A little clue, like Dr. Seuss's Who's.
A little who? Oh, like the Who's Not in Whovilles? Yeah. Are they really small? I didn't realize that. So is the Grinch like that big? I guess I didn't realize that.
He's like a snowflake.
Oh, so it's like Gargamel and the Smurfs. See, you gotta give it reference.
No, they are this big.
They are?
There's a Dr.
So it's about the size of your chance of winning the iPad. But you gotta realize that your chance is the same as anybody else's. It's not like you can bolster your chances by doing more. I mean, it's just your chance. It's a chance. It's a chance. What I'd like to see is if there is any difference in the number of people that do them with the iPad. Have they always done the iPad giveaway?
No.
They haven't. They just started it?
I was doing it beforehand. Like I always just did the
It'd be interesting to see if the numbers exploded measurably. This is the kind of stuff we do in 244 all the time. See if they went up statistically after the iPad got instituted. I have no idea. What's that? Well, Barbara the lady who was in charge of that just left, and the new lady I haven't met yet, so I'm sure we'll be chit-chatting quite a bit. Well, because of me, probably. Miss you already, Barbara. I miss you, I do. So, okay. So, anyway, Joanne, there's your answer to your question. Hopefully it helped. That's why I also put hint the answer is not 9, which I know is very tempting to do. It's 3 squared, 3 times 3. Well, the problem with 3 times 3 is that means that people can take codes more than once. Right? And that doesn't happen here. So this is like an iPod Shuffle with 3 songs on it. This is like an iPod Shuffle with 3 songs that you play 3 times. If you simply turn your iPhone on shuffle and hit play in a playlist, you will hear every one of those songs one time in some random order. So if you have 3 songs loaded into your iPod and hit shuffle, you're either going to hear the first, second, third, first, third, second, second, first, third, second, third, first, third, first, second, third, second, first. That's all you could possibly hear. That's it. If you start shaking it in between, you might hear like 3-3-1 or 2-2-2 or 2-3-2 or something like that. And if you simply let it play through, the reason they call it shuffle is brilliant, I think. Shuffling on your iPod is like dealing a deck of cards out to somebody and not putting the cards back, right? That's the difference. Random would be deal the card, look at it, put it back in, and shuffle. That's what I had you guys doing in here. But shuffling is not like that. It's like a deck of death. If you've ever done a deck of death work, I know some of you guys have. When you have a full deck of cards, you throw the card out, the card tells you what exercise to do and how many to do it. Then you throw the next card out. In other words, the first card you'll never see again in that workout. That's what a shuffle is, just like shuffling out and dealing to someone.
That sounds horrible and amazing at the same time.
It is both horrible and amazing, sometimes rapturous. But that's the difference between a shuffle and purely random. There is some randomness in a shuffle, but the shuffle itself, you'll never hear a song more than one time.
So is that, it plays like the same, like, there's a whole bunch of songs on mine?
Yes?
And it plays like the same 10 when I put it on shuffle.
Well, it depends. Are you starting and stopping the shuffle as you... Sometimes, for example, you listen to a couple songs, turn it off, then turn it back on again?
Sometimes.
Well, then that's not a shuffle anymore. It's a new shuffle. You have to let it play all the way through. It's like dealing the cards out. If you deal 5 cards out, oh crap, I screwed up, pull the cards back, reshuffle, and deal again, you might see the same cards again.
I have a question though. On this up here where there's only 6 outcomes, I did put that there were 6 possible outcomes.
Did you list them all out?
I explained what it was.
Well, as long as you explain what it was and they're there, it's going to be a break and we'll fix it. But you have to actually have them out to get the points for it.
Oh, I didn't do that, but I explained
Well, then
what
you don't
it
get the
was.
points for it. That's why I said on there, you have to have the outcomes written out. Just the tree by itself is helpful to get the outcomes, but this is actually the solution right here. Yeah, sorry. Let me not look.
I got it right. I think it half a time.
Okay, makes sense? Joanne, thank you for the question.
That question,
Uh-huh.
is it a random or is it shuffle?
It's a random. So in other words, you can that's why I say in there somewhere you can hear the same song more than one time. That's why it's a random, not a shuffle. Fair?
Fair.
Good. All right.